everybody, welcome to Calculus. Today we are on day 2 of our straight line motion study. Last class we looked at how position, velocity and acceleration are related to each other. Today we are going to work some more with position, velocity, and acceleration. But this time, instead of doing a lot of graphical analysis, we're going to do more algebraic analysis. So this unit, you notice we've done graph, algebra, graph, algebra, graph, algebra, and then how the calculus relates all to that. So we keep circling back, but hopefully that's helping you learn a little bit better and not forgetting about your graphical skills. So just as a reminder, position is x of t. Sometimes you'll see it s of t. The derivative of position is velocity, and the second derivative of position, or the derivative of velocity, is acceleration. So we'll be working back and forth between position, velocity, and acceleration. Then we also have this nice chart where we have some characteristics of whatever position's doing that tells me what the velocity graph would be doing. So just double check, make sure you have this down in your notes. Also some notes about speed. You can tell if an object is speeding up or slowing down. And then speed is the absolute value of velocity. So taking this, we're going to do some more algebraic analysis. So here we go. All right, so your assignment is set up into 3 sections. The first section is particle motion from equation level 1. So these are examples that help with that first section. So here's a question you'll have. A particle moves along the x-axis so that time t is greater than 0. Its position is given by this function. Determine if the particle is speeding up or slowing down at t equals 7. So when the time is 7, is the particle speeding up or slowing down? Now, you'll have a box that pops up where you can have that kind of guides you through this. But to tell if an object or a particle is speeding up or slowing down, we can look right here. An object is speeding up if acceleration and velocity have the same sign. An object is slowing down if acceleration and velocity have opposite signs, so being positive versus negative. Now, this last option would help us if we knew the graph of position, but remember, and yes, I could graph this on a graphing calculator and analyze it that way, but this is how do we analyze the formula. So we're going to go with looking at signs. So they do give me a hint. I need to find v of 7 and a of 7. So first of all, if this is x of t, then I need to find v of t. So v of t, velocity is the derivative of position. So v of t would be derivative of t squared 2t. Derivative of 5t is 5. So then v of 7 would be 2 times 7 plus 5. And 2 times 7 plus 5 would be 19. So I would type 19 right there. Then I need to find acceleration. Well, acceleration is the derivative of velocity. So I take the derivative of velocity and get 2. And then I need to find a of 7. So that would mean I substitute 7 in for t, but there's no t. So then a of 7 is equal to 2. So a of 7 equals 2. So then I need to figure out, is this particle speeding up or slowing down? Well, since 19 is positive and 2 is positive, the particle is speeding up at time equals 7 because velocity and acceleration have the same sign. So this is how things are going to look today. Here's a similar one. Particle moves along the x-axis so that at time t is greater than or equal to 0, its velocity is given by that formula. Determine if the particle is moving to the right or moving to the left at time equals 3. So we have a formula for velocity. I need to know v of 3, so we'll go ahead and find v of 3. Just substitute in 3 for each t. So v of 3 is negative 3 times 3 squared plus 4 times 3 plus 7. So when I do all that, I get that v of 3 equals -8. So since v of 3 equals -8, that number you'll have an option to choose if it's less than 0 or greater than 0. So -8 is less than 0. Then I have to determine if the particle is moving to the left or to the right. So just a reminder, going back to that chart. For velocity, if I'm looking at velocity, an object would be moving left if you're moving horizontally, or down if velocity is negative, or in right if velocity would be positive. So since I have a negative number, the particle is moving to the left at time t equals 3. And the next one, particle is moving along the x-axis at time t is greater than or equal to 0, and velocity is given by v of t equals -2t minus 13. Now we have to determine the speed of the particle. Well, velocity and speed are not always the same thing, because velocity gives you the speed and the direction. And now I just want the speed. So for this one, you need to remember that speed is equal to the absolute value of velocity. So let's go ahead and find, let's see, if I want to know the speed at t equals 2, then I need to take, let's just let speed equal s. So that way I don't have to write everything down. So if I want to know s of 2, I'm going to need to take the absolute value of v of 2. So speed at time 2 would be absolute value of -2 times 2 minus 13. So s of 2 would be the absolute value of -4 minus 13, so -17. And the absolute value of -17 is 17. So the speed of the particle at time 2 is 17. Now this one's going to take a little bit more work, because this time we have to determine when the particle is at rest given the position function. So here's my chart again. I know when the particle would be at rest if there was a relative max, a relative min, or a horizontal tangent line. But again, I'm not trying to analyze position graphically. I'm trying to analyze it with the formula. So my other option is to figure out when velocity would be equal to 0. So that's what I'm going to do for this one, because I'm trying to find the algebra way to do it. So I'm going to find my velocity function. I'm going to set it equal to 0 and solve. So first of all, I need velocity. So v of t equals 3t squared plus 12t minus 36. And I want to figure out when velocity is equal to 0. So 0 equals 3t squared plus 12t minus 36. I can factor out a 3. So 0 equals 3 times t squared plus 4t minus 12. So 0 is going to be 3 times, let's see, a t here, t there. What if I do a 6 and a 2, positive 6 minus 2? That would multiply to be -12 and add to be positive 4. Okay, so solving this, I'll get that t equals -6 and t equals positive 2. So it looks like the times the particle would be at rest would be t equals -6 and t equals 2. Just be careful though, because they give you that the particle moves along the x-axis so that at time t is greater than or equal to 0. So that, like, t would be the initial time. So we do not take any negative values for t into account. So I won't give this one, because t equals 2 is the only value in the interval where t is greater than or equal to 0. So t equals 2 is what you'll enter into your answer, even though we got two answers. Just, you got to make sure it matches what they say where t needs to be. So that was level 1. All right, now let's try some level 2 type questions. Level 2 is a little less guided, but here is here's just a reminder of that again. Okay, so this time particle moves along the x-axis so that at time t is greater than or equal to 0. So I'll just go ahead. That was important last time, so maybe it'll be important again. Its position is given by this formula. Determine all the intervals when the particle is moving to the left. Again, here's that chart. How do I tell when the particle is moving to the left? Well, a couple of ways. Moving to the left when position is decreasing, but I don't have the graph and I'm not going to graph it, so that's not looking like it's a good option right now. But I could also tell whenever velocity is negative. So our plan for this one, we're going to try to figure out where velocity is negative. So first of all, let's find a formula for v of t. V of t equals 3t squared minus 30t. Now, I do need to figure out where velocity is negative, but first I'm going to find where velocity is equal to 0, because then that's going to let me set up my number line and find positive and negative intervals. So set it equal to 0. I can factor out a 3. And looks like I'm getting that velocity is 0 at t equals 0 and t equals positive 10. So since I know when velocity is 0, now I'm going to be able to figure out where velocity is negative by setting up a number line. So I'm going to set up a number line. But this time I'm only concerned for the t values that are greater than or equal to 0. So my number line doesn't go to negative infinity anymore. It's only going to go to 0. So it starts at 0 and then goes on, which happens to be one of these numbers here. I'll put 10 on here. And remember I said it's easier to substitute in values into the factored form. So I'm going to substitute in values into 3t times t minus 10. So let's substitute in maybe a 2 for this part and 20 for the second part. So if I substitute in 2, 3 times 2 is positive, 2 minus 10 is negative, and a positive times a negative is negative. And then for 20, 3 times 20 would be positive, 20 minus 10 would be positive, positive times positive is positive. So these are the signs for velocity, which means the particle would be moving to the left on the negative interval and then right on the positive interval. So this question asks all the intervals where the particle is moving to the left. So I would say everything from 0 to 10. Put parentheses around it, but I don't think you're not going to be counted wrong for parentheses or bracket on here. So it's the numbers that are important. And then another one. So a particle moves along the x-axis so that at time t is greater than or equal to 0. So again, that's coming into play. Mostly because if you had a negative value for t, it's like you're going backwards in time. If its position is given by another position formula, this time we want to know when is acceleration positive. So don't really need my chart for this because I'm just trying to figure out when acceleration is positive. So I am going to need the acceleration formula. Well, position's given. The derivative of position is my velocity formula. So I need velocity to get to acceleration. So go ahead and take the derivative. Derivative of t to the 5th is 5t to the 4th minus 20t to the 3rd. And then I want to find the second derivative of position, which is the derivative of velocity, which is acceleration. So acceleration is, let's see, derivative here, 20t to the 3rd minus 60t squared. So I am going to find where acceleration is positive, but first I need to figure out where acceleration is equal to 0. So find where a of t is equal to 0 first, then we'll find the positive interval. So set a of t equal to 0. And solve. So I can factor out a 20t squared That leaves me with t minus 3. So if I solve that, t would be 0 and t would be positive 3. So then I can set up a number line. I'm only going from 0 to infinity, so started at 0, put a 3 here. And I am testing in the acceleration formula in the factored form. So 20t squared times t minus 3. So some values to test. Number in between 0 and 3 could be 1. Between 3 and infinity, maybe 5. So if I substitute in 1 for each t, I'll have a positive times a negative, and positive times negative is negative. If I substitute in 5, 20 times 5 squared is positive. 5 minus 3 is positive, so positive times positive is positive. So I need all the intervals where the acceleration is positive. That would be this set right here. So it looks like everything from 3 to infinity. Now this next one is a little interesting, takes a little bit more analysis. This time we have a particle moving along the x-axis so that at time t is greater than or equal to 0, its velocity is given by that formula. Determine all the intervals when the speed of the particle is decreasing. And I also have this reminder, hey, here's what you need to know about speed. So I want to know when the speed would be slowing down. Now we're not analyzing graphically, so this last option, not the best way to go for what you're trying to learn how to do. We want to know when the object is slowing down. So I need to look to see where velocity and acceleration have opposite signs. So to do this, I'm going to make a sign chart for the velocity and the acceleration functions. I'm going to try to color code everything so that everything we do with velocity is in red and everything we do with acceleration will be in blue. And we're going to make a sign chart, but we're going to put it all onto one sign chart. So first of all, let's work on velocity is already given to me. They give me the formula for velocity. To make a sign chart, I'm going to have to set velocity equal to 0 and solve. So, because I need to know where velocity is 0, and then I can determine the signs on the intervals. So I'm going to set the velocity function equal to 0, negative 3t squared plus 30t plus 72. I can factor out a negative 3. That would leave me with t squared minus 10t minus 24. Then if you factor t here, t there, looks like it would factor into negative 12, positive 2, because we need them to multiply to be negative 12, but then negative 12t plus 2t is negative 10. So just be careful right there, because I know it's really tempting to pick 6 and 4. Solving this, I get that t equals 12 and t equals negative 2. But remember, we're only concerned when t is greater than or equal to 0 for this question, so I don't worry about that one. So let's make a number line. I'm going to make it in black because I'm also going to put the acceleration on here as well. Started at 0 and then time 12. So up here I'm going to do my velocity. So v of t, in factored form, it's negative 3 times t minus 12 times t plus 2. So let's say I wanted to test the number 1 and maybe 20. All right, so if I test the number 1, and for each t right here, I'll have negative 3, which is negative, times negative or 1 minus 12 is another negative, and 1 plus 2 is positive. So negative times positive is positive. So right here, velocity is positive. If I'm testing 20, negative 3 would be negative. 20 minus 12 is positive. 20 plus 2 is positive. A negative times a positive is negative. So this whole section would be negative. Okay, so made a sign chart for a velocity. Check. Now I'm going to make a sign chart for acceleration. So now I need a formula for a of t. Acceleration is the derivative of velocity, so I'll take the derivative of the velocity function. Derivative of negative 3t squared is negative 6t. Derivative of 30t is plus 30. Set it equal to 0. Equals negative 6t plus 30. I see that you guys have been factoring, so let's just go ahead and factor. Factor out a negative 6. That will leave me with 6 minus 5, so t would be 5. Okay, so now with acceleration, I'm going to add a 5 here. And that does split from 0 to 12 up into 2 intervals, but we said velocity was positive up until 12. So I'm just going to add another plus sign right here. So these are all of my signs for velocity. Then down here, I'm going to add all my signs for acceleration in blue. So my formula for acceleration in factored form was negative 6 times t minus 5. So I have 3 intervals to test, one between, actually I only have 2, but we'll test 3. One between 0 and 5, one between 5 and 12, and then a number between 12 and infinity. Let's try 20 again. Okay, so if I substitute in 1, I'll have a negative 6, which is negative, times 1 minus 5, which is negative, and a negative times a negative is positive. Then if we try 10, I would have a negative, and then 10 minus 5 is positive. So negative times positive would be negative. And then if we test 20 for t right there, I'd have negative 6, which is negative. 20 minus 5 is positive. And so negative times positive is negative. So this interval, negative. Which we knew that was going to happen because really for acceleration, I divide them. My acceleration number line would look like this, where I'm just testing 5. So I'd have a plus and a minus. It's just this 12 came from velocity, so kind of separated it. But if you test it like that, it makes it easier to spot. So I made a sign chart for acceleration functions. Now my goal is to look to see where the speed of the particle is decreasing or slowing down. And to do that, I want to look and see where acceleration and velocity have opposite signs. So on the first interval, I have positive for velocity, positive for acceleration. I'm looking for opposite signs, like right here from 5 to 12. Positive velocity, negative acceleration. So right here. This is the interval I'm looking for. And then right after 12, both negative. So the particle is slowing down. From t equals 5 to t equals 12. So now let's move on to the third section. In this section, we're going to be finding distance using derivatives or a graph. So we've got 2 examples here. First one is using a graph. So we have the graph of position, and I want to find the total distance traveled by the particle. So total distance traveled. Okay. So I need to know how far the object went when I'm given position. This only tells me where the particle is. So I know that at time 6, the particle is at like number 4 on the number line. And then at time 9, the particle is at number 4 on the number line. So you could look at this and get it. I'll also show you how to figure out what's happening. But basically, if the position, we can tell what's going to help with the formula way to do this is if we do it this way. So listen to it this way, and then we'll do the formula way as well. Okay. So my position function, it starts off, it's decreasing. So that tells me my particle is going to be moving to the left first or down, but we'll just say it's moving horizontally. Yeah, it's moving horizontally right here. So it moves to the left. So right here, it's moving to the left. Okay. Then when my function is increasing, when position is increasing, the particle would move to the right. So up until x equals 6, the particle moves to the right. And then the position decreases, so the particle would move to the left again. And then increases, 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 so the rest of the time it's moving to the right. Okay, so here's some things that we can do. We can make a table for each time, so I can say time, and then what position it is in, and then the distance traveled. And I'll do this for every, what I've done, I've created interval. So for every interval. So at time 0, the position is 5. And then at the end of this interval at time 2, the position is -4. So the distance would be how far it traveled. Now I do have these lines here, but how far did it travel? From -5 to 4. So from -5 to 4, that's 9 units. It's like a number line. So it went from here, from -5 to 4. Okay. Then that was my next interval. So then from at time 6, the end of this next interval, the position is 4. So how far did it travel from -4 to 4? So from -4 to 4 is 8 units. And then the next position I need to look at is at time 9. Time 9, the position is -4. So then from 4 to -4, that's another 8 units. So I'm counting like the vertical units change right here. So from 4, 1, 2, 3, 4, 5, 6, 7, 8 units to get down here. And then it moved to the right all the way until time 18. At time 18, its position is 7. And so then it moved from -4 to 7. It moved 11 units. So then the total distance, I'm going to add up 9 plus 8 plus 8 plus 11. And I get 36. So 36 units. So you'll do a couple with a graph. Then you have to actually look at the formula and do it. So we're going to try to do the same thing. So we're going to try to figure out when the particle moved to the left, when it changed direction, moved to the right, when it moved to the left, when it moved to the right. To do that, I need to analyze. How do I analyze the direction? Hold on, I need an arrow here. I analyze the direction by looking at the velocity. When velocity is positive, particle will move to the left. When velocity is negative, particle will move to the right. So I have this formula. So the first thing that I'm going to do is I'm going to analyze velocity to determine when the particle moves to the right or left. So let's do that. Let's get the velocity function. So the formula for velocity is 6t squared minus 24t plus 18. Derivative of 25 is 0. Set that equal to 0. 0 equals 6t squared minus 24t plus 18. I can factor out a 6 to be left with t squared minus 4t plus 3. Factor that. Let's see, looks like I could do minus 3 minus 1. So t would equal 3 and t would equal 1. So I'm going to analyze the velocity function. Use the factored form to make your multiplication easier. And I'm only going greater than or equal to 0, so 0 here. Okay, let's see, I'll put 1 and a 3. Now if I substitute in like the number half, 6 is positive, 1/2 minus 3 is negative, 1/2 minus 1 is negative. So positive times 2 negatives becomes a positive. Then if I subtract the number 2, 6 is positive, 2 minus 3 is negative, 2 minus 1 is positive. Positive, 2 positive times a negative is negative. And then after 3, so like maybe 4, 6 is positive, 4 minus 3 is positive, 4 minus 1 positive. Positive times all those positives is positive. So we're going to analyze the velocity to determine when the particle moves to the right or to the left. Okay, so when the velocity is positive, the particle is moving to the right. Velocity is negative, particle would be moving to the left. Velocity is positive, particle moves to the right. So this gives me information on how I can know which intervals that I need to find the position at each interval. So after I've analyzed velocity, now what I'm going to do is I'm going to find position at the endpoints of each interval. So I'm going to have time, and then I'm going to find the position at each time. Then after that, I'm going to calculate distance. So first interval from 0, then 1, then 3, and I'm like, where? This looks like it goes on to infinity, but the problem tells me I'm going from 0 to 4. So I need to put an endpoint here, 4. All right, so now I need to find x of 0. So I'm going to substitute 0 in for each x, and I get 25. Then I'm going to substitute in 1 for each, not for each x, for each t. Put a 1 here, put a 1 there. When, let's see, when t is 1, looks like I get 33 for position. Then substitute in 3's for all those t's. So put a 3 here, 3 there, 3 there. Substitute in 3, you get 25. And then finally substitute in the 4, you should get 33. Okay, so it looks like the particle started on the 25 mark on the number line, and then it stopped when it was at 33. But it did move to the right, and then to the left, and then to the right. So let's talk about how much distance was covered. Well, from 0 to 1 second, it was moving to the right, and 33 minus 25 looks like it moved to the right 8 units. Then from 1 to 3, the particle was moving to the left. Looks like it moved to the left 8 units. Then from time 3 to 4, the particle moved to the right again, and it moved also 8 units to the right. So what is the total distance traveled? I add up all of those 8s, 8 plus 8 plus 8, 24 units is the total distance traveled. So good luck with this assignment. Hope this works for you. If not, you know where to find me. Have a great day.